Hi, hello everyone. So this is the video dealing with section 6.1, law of sines, and I've divided the videos dealing with this section in two parts. The first part is where we're going to cover the law of sines dealing with non-ambiguous cases, and the second, we're going to cover situations where when we apply the law of sines, we may get an ambiguous case. Okay, so first of all, the law of sines is a one type of relationship. There are many relationships that we can get on triangles. This is one type, which is called the law of sines. So you can see right here, okay, for any triangle, okay, this is the law of sines is true for any triangle. However, we don't really apply the law of sines on a triangle that has a 90-degree angle, meaning a right triangle. The reason we don't do that is because if we have a right triangle, you probably know there is another property that may be more useful, which is the Pythagorean theorem. However, the law of sines work on any triangle. So normally then we apply the law of sines on what we call oblique triangles. And an oblique triangle is any triangle that does not have a 90-degree angle. So I can have a triangle that looks like this, right? So where all of the angles are less than 90 degrees, or we can have a uh, triangle that has one angle bigger than 90 degrees. And then the other two angles are small. Okay. You probably know, and we should know this. This is especially going to be true when we apply the law of sines or in section 6.2 for the law of cosines, that the sum, let me just clarify this here. For any triangle, I'm going to call this alpha 1, alpha 2, and alpha 3. The sum of these three angles for any triangle has to be exactly 180 degrees. Okay, so this is important to know. So the law of sines is very simple. It has to do with the ratio of a side over the sine of that angle. Okay, so A over sine of the angle A is equal to B over sine of angle B, which is equal to C over sine of the angle C. So it doesn't matter which triangle you look at. So here is, for example, angle A. Here is the side A, right? Side A is the opposite to the angle A. Here's sine B, angle B, side C, angle C. So normally we refer to sides with lowercase letters and with angles or two angles in capital letters. Okay, so our goal in whatever problem we're going to be doing in this section is to solve the triangle. So when we say solve the triangle, we mean that we have to find all the sides and all of the angles of a respective triangle. Okay, so whatever problem we're dealing with, if we're missing, for example, these two sides and maybe one angle, we have to find this angle and we have to find the remaining sides. Okay, if we're given two angles and then maybe one side, all we have to do is find the angles and find the side or whatever combination that we have. Okay, so this is what solving a triangle means. Now, the application is extremely straightforward. And we're going to see two examples in this first part of section 6.1. So here's the first example. I'm going to try to keep the law of sines here, even though it's very simple and you probably can remember. So here's a typical example, and this is the example you might see on an exam. So solve the triangle shown in figure 6.3. I didn't put the figure in because on the exam, we may not have the picture. So we have to be able to draw a picture. Okay, it doesn't have to be a perfect picture, but it has to be somewhat accurate to the information given. Okay, so here's the information that we're given. We have to solve the triangle, which you already know, means find all the sides, all the angles. So I'm going to draw a triangle. It doesn't have to be representative to the information, but somewhat so that you can visualize where you are. And it doesn't matter which angle is A, B, or C. So I'm going to label this A, this B, and this C, which means that the opposite to angle A is A, side opposite to the angle C is C, side opposite to the angle B is small b. So they're saying that A is 46 degrees. Angle C is 63. So angle C is 63 degrees. And side C is 56. So here's side C, 56 inches. All right. Now, remember that to solve the triangle, I have to find all of the sides, all of the angles. This I already have. C, I already have. I need to find angle B. Okay. And this is very easy because how would I do that? Well, I know that the sum of the internal angles of a triangle is 180 degrees. So it's easy enough to do the following. So angle B plus A, 46, plus C, 63, has to be 180 degrees. So then I'm just going to subtract 46, subtract 63 from both sides, and I should have B. All right, so then you can do this on the calculator. You can do it in your head, whatever you want to do. I'm going to do it here so you can see. 180 minus the 43 minus the 63, it gives me B equals 74 degrees, as you can see here. Okay. So I'm going to write here 74 degrees. Make sure you put the units in. So now I have this also. Now I already have C. I need to find A and I need to find B. Now, the only property that we have on the triangle that, we can use is the law of sines. So how do we apply this? Now, it's important to realize the following. I have this triangle that you see, and this is the law of sines. I need to be able to use one of these fractions where I have a full ratio. I have the numerator and denominator. Otherwise, it becomes useless. Now, the only full ratio that I have, as you can see, is C, because I have the angle and I have the side. So I have to use something with this. So I'm going to write it here, C over sine C equals, and then pick one of the other two because they're both similar. We don't have the other side. So maybe I'm going to find A first. So 8 sine A. Okay. So now I have side C, which is 56. I have the angle C, which is 63. So sine of 63 equals A, sine A. This is what I'm looking for. And I have sine A, which is 46. So this is what I have. Now I need to solve for A, so I am going to multiply both sides by, and I'm going to do this here on the side. I'm going to multiply both sides by sine 46 degrees. So I'm going to squeeze it in here. Now look what happens. On this side, this cancels with that. And I'm left with A equals sine of 46 times 56 over sine of 63. All right, and I have to do this on the calculator, obviously, to find what the answer is. So I'm going to go to the calculator. It doesn't matter which one. I'm going to use the TI-84 now because you are allowed a TI-84 on this course. So let's do this. So I'm going to put 56 times sine of 46. And you have to make sure that your calculator is in degrees, okay? In fact, I'm going to check it before, go to mode, and you can see here degrees. All right, so that's fine. All right, so we go again, 56 times sine of 46 times, nope, divided by sine of 63. So sine of 63. On the graphing calculator, this is easier than on a scientific. So I get an answer that is 45.21. 45.20. Now this is the side, okay? It's not an angle. So this is 45.21. The units is inches. So inch. So now I have A. All I have to do is I have to do the same thing for B. All right. So let's see if I can squeeze it in here. I don't know if I have enough space. And I'm going to do it over here. So I'm going to use the same ratio of C sine C, but now B sine B. Okay, because that's the last thing I need to find. Now, C sine C again is your 56 over sine of 63. Right, so just let's confirm 56 sine of 63 equals now B over sine, and we found B, which is 74. All right, and just as before, I'm going to skip that step. I'm going to multiply both sides by this quantity here so that I end up with the following. So I'm gonna do here on the side so you can see sine 74. This will cancel with that, and it'll appear over here. So my B is going to be this quantity here. 56 times sine of 74 over sine of 63. All right, and then I am going to do this on the calculator, obviously, because I cannot do it in my head. Same thing as before, make sure that your calculator is in degrees. It is 56 times sine of 74 times, nope, divided by sine of 63. Sine 63, and we get 60.4. 60.4, whatever we said, 41, 41. Okay, inches. And then we found everything. We found B, we found small b, and we found small a. We're done. So all we have to do is this. Now it's important to notice, and this is going to come up later, especially when we do the ambiguous cases or the law of cosines, that you have to remember that the largest side, okay, the largest side has to be opposite to the largest angle. So in this case, B 74 was our largest angle, which means that small b has to be our largest side. And we can check that, right? So B is 60 and C, what was C? 56, so that checks. So we're okay. Because sometimes you may do a problem and you get the wrong answer, and then that would disqualify that as a solution. All right, so this is all we have to do for solving this particular triangle. Let's do another case. Let's see another case, but it's very, very similar. Okay. Here's the other case. So in this case, notice they didn't give us a picture. So they're just saying solve the triangle ABC if A is this, C is that, and side B is that. So we have to be able to come up with a picture. It doesn't have to be a representative picture. You can just write it this way, and you can always put the angles wherever you want, but make sure that whatever you write for the angles, the opposite has to be the small case letter representing its respective side. So this is A, this is C, and this is B. Now A is 50 degrees. Angle C is 33.5 degrees. So it's customary on problems dealing with the law of sines and cosines that the angles be given in degrees, not radians. All right. And side B is 76. So this is identical to the previous problem. All right. But now we have a situation that, again, we are given two angles. Okay, and we do not have a ratio. So remember in the previous case, we were given a situation where we had a full ratio. Here we do not. All right, but that's okay because we are given two angles, and the very first thing that we're going to do is find B again. Right? So B plus 33.5 plus the 50 degrees has to be 180. So I'm going to subtract 33.5. I'm going to subtract 50. And I'm going to subtract that on the other side as well. And they will cancel here. And I get, and we do go to the calculator for that. So 180 minus the 33.5 minus the 50. And we got 96.5. It's perfectly okay. It's not a, oh my God, it's not a whole angle, right? It doesn't matter. This is perfectly okay, right? So I just confirmed that I didn't enter the thing wrong, 96.5. So this is my angle, right? So notice this is an angle greater than 90 degrees. So obviously my picture is not very representative to this case. So the triangle would be something like this. Okay. So this would be the triangle because B is over 90, but that's fine. You can use this one. Okay. Okay. We don't need this. Okay. We just have to be aware of the situation. And I'm going to remind you at the end that the side B, oops, remember what I told you a few minutes ago. If B in this case is the largest angle, then small b must be the largest side. Otherwise, we have a problem. Otherwise, either you do not have a triangle or you made a mistake somewhere. So this is very important that you notice and you check that in your work. All right. All right. So I already found to solve the triangle, right? I have to find this angle, that angle, and this angle, which I already did. I already have side B. The only thing missing is side C and side A. But as before, in the ratio, I must use one full ratio. So I have to use B over sine B. And then whichever one I want to start with. I'm going to start with A. I'm going to find A first. A sine A. All right. And again, I am going to multiply both sides by sine A because I'm solving for A, small a, right? So here they will cancel. And I'm left with small a equals sine A, which is 50 degrees, times the value B, which is 76, over sine B, which is, what was the angle that we found? 96.5. 96.5, and let's see what that is. So we go to the calculator for that. So sine 50 degrees, right? You're going to make sure that the calculator is in degrees for that. And then divide that by sine 96.5. And we get 58.59. You can say approximately 58.6. Notice that in here, they don't even say, they just say round measures to the nearest tenth. We don't know what the units are, so we would leave just 58.6. That's fine. Okay. Normally a problem will have the units. So we found A. All we have to do now is find the side C. And now that you have a full ratio, if you don't want to use B, the side B over angle B, you can use A over sine A, which is perfectly fine. So I'm going to do this. A over sine A equals, and now I'm looking for C. So C over sine C. And I'm going to multiply both sides by sine C. Here they will cancel. And my answer would be C equals sine C, which is 33.5, times the side A, which we found to be 58.6, divided by sine A, which is 50 degrees. So this is my answer, and I'm going to approximate that again. Clear that. So sine 33.5, sine 33.5 times 58.6 divided by sine 50, right? And we get 42.2 approximately. 42.2, whatever units. And then we check, all right? We have to check. So the check is sufficient if you just do check the largest angle has to be opposite to the largest side. Now, in this case, B is 96.5 and the side B is 76, and that checks because C and A have to be smaller. And they are, so we're good. So we solved the triangle, we found all of the angles and all of the sides, and that's the end of the problem. Okay, so this is exactly all that we have to do in section 6.1, the first part with the non-ambiguous cases. It's very simple. The answer is always one solution, or maybe if they gave you something that is not a triangle, and it's going to be obvious. And I guess in the next case, you see that example.